Welcome back. My name is Keith Parsons, and we're here with Wireless Non-Professionals. And today we have a special guest, George O. I've been following George for literally decades in his writing. He's been writing about telecommunications and how to make networking work for Tech Republic, for Network World, I think, but been reading his stuff for a long time. And just last week, we were having a DM discussion on Twitter about a solution that he came up with using kind of a mixture of home gear and Ubiquity gear to solve a problem that they were having in their executive homes. So I thought, hey, we ought to bring him on. George, welcome.
Hey, thanks for having me.
How did you get into networking? Give a little history of how you got to here over the last couple of decades.
I actually started out in networking. I kind of moved around into journalism, tech writing, and then later on public policy and think tanks. And now I'm kind of back into IT with unified communications. Did some audio, video production, broadcast, and a lot of voice over IP and video communications. So it sort of requires me to bring back some of my old skills because everyone has the same issues with Zoom being glitchy. Not just executives. I mean, all home users. Everybody's working from home, learning from home, playing from home. So, typical use cases, someone's working from home and doing a lot of Zoom meetings, and their spouse and their kids are also on Zoom at the same time. Or they're doing other things like downloading big files, and that presents a lot of challenges in terms of keeping the latency low enough to allow Zoom and online gaming to have a smooth experience.
We've all lived through the problem over the last, many months in the COVID time of getting Wi-Fi in the home, not just Wi-Fi, but the entire network. So what made you think that you could solve the problem with different hardware at the RF layer rather than just a fatter pipe?
I've just seen so many times where we have users that can get a reliable 300 megabit per second on speedtest.net. So they can show me all day long, hey, look, I'm getting 70, 100, 200, or even 300 megabit per second. But for whatever reason, I'm getting occasional cutouts in Zoom, where Zoom is just freezing or the game is freezing. It's just getting laggy. And then I'll do the test, and I'll do a continuous ping test where you ping the default gateway. So we're doing a test where you're just measuring the latency inside the house, and we're seeing latency anywhere from 20 to 600 milliseconds. So normal latency is less than 4 milliseconds inside the house. But when you have issues or any kind of Wi-Fi disruption, whether it's contention or low signal, you're going to see the latency jump up to 200 to 600 milliseconds.
Obviously, that causes issues for whoever's doing there. So one of the options could have been to go to enterprise class gear, replace their Soho type gear and put in the Cisco Aruba Ruckus or something like that. Did that cross your mind, changing out the hardware?
I know that would not work because we have the same problems at the enterprise level. And in fact, at the enterprise level, people will actually tell me the official line from Zoom is we don't support Wi-Fi. We don't recommend Wi-Fi, and we recommend people go to wired connection. And that doesn't help anybody because the vast majority of people, almost 90% of the case, is on Wi-Fi. So you can't just tell people we don't support Wi-Fi. I mean, the official answer you get from everybody, whether it's Zoom or whether it's the network support team, is we don't support Wi-Fi for real-time applications because we cannot guarantee, with the Wi-Fi protocol, we cannot guarantee, at least the current standards, we can't guarantee any kind of latency, any kind of real-time metrics for you. So I did the same latency measurements in some enterprise offices. Using Cisco gear. It doesn't really, I don't want to blame Cisco. It's the same thing. As soon as I put 5 users on the same Wi-Fi channel, and having 5 video conferencing sessions, you saw the latency go up to 200 to 400 milliseconds, even on enterprise gear. So I know it wasn't really an issue of whether you're using consumer gear or enterprise gear. It was just a question of having the AP in the same room. That seems to be the most important thing. If you have to go to the opposite end of the house it seemed to be more, the latency problems seemed to be more consistently bad.
I'm going to put up the slide that you gave us of the just kind of a quick little network diagram. While I'm bringing it up, you want to discuss, was this your first or your fourth iteration before you kind of figured out that this solution worked?
Yeah, this is sort of one of the later iterations of it. The general design has been more or less the same. On the upper left-hand corner, we have where the user typically sits. Either it's upstairs or it's somewhere far from the ISP's equipment. So Comcast is on one corner of the house, and they're working in the other corner of the house. And the problem is how do you get the Wi-Fi signal reliably from one side of the house to the other? Now, most users would go to the store, spend $400 on a mesh network, and the end result would be 70 megabit per second with very, very high latency.
What about using just cables? If there was a wire in the office, wouldn't have that solved the problem?
Cables would be the ideal solution because that you can push one guaranteed less than 1 millisecond and up to 10 gigabit per second with a piece of wire. The problem is how do you get that wire there? And probably 9 out of 10 times they're not able to do that because you're talking about hiring a contractor. One of our users actually came back to me and said that, hey, I got a quote for a wire contractor, and he said it would cost me $2,000 to run a wire from one side of the house to the other. So I think in most situations, running a wire would not be feasible for most users because they just don't want to have to go through the trouble. We've had a few users that did actually go and do the wiring themselves, and in that situation, I always recommend running a wire whenever possible. But we have to be practical and say, look, how do we address the 90% that either can't or don't want to run a wire?
And so you were saying one of the options, and a lot of people have gone this option, was to put in a mesh network, but that has its own other issues. And did you try the mesh for a while and see if that solved the problem?
We've probably replaced about more than 20 mesh networks so far. Every single time, same result. Every single mesh network I've measured, they have a baseline latency that's higher because you're going through multiple Wi-Fi links, right? You're going through the backhaul is Wi-Fi, and then they have another Wi-Fi link on the endpoint. And so for whatever reason, I'm always seeing baseline latencies of 20 milliseconds or higher, and then more frequent spikes in latency. So, and the other problem is that they're limited to about 70 megabits per second. Even if they're purchasing 500 gigabit fiber, when you can get 600 megabit if you plug directly in, they're only seeing 70 megabits. And so when I replace it with this system, I'm able to fully saturate 500 megabits. I
just have to ask while you're here, another copper option is to go with Ethernet over power, not power over Ethernet, the reverse. That has its own issues. And so did anyone try that as the solution instead of copper?
We actually tried that first, and it works well most of the time. So whenever possible, we were using that. But two problems came up with that. One is you were limited to about 90 megabit per second on average. Maybe it bursts up to 120, but on average, you get about 90 megabit per second. The other problem is that in roughly 1/3 of houses, it didn't work. So for whatever reason, the circuit breakers, maybe it's the circuit breakers or whatever it is, it prevents the signal from getting through. So we had a very high failure rate. So you're going to ship this box out, or they're going to drive in and pick it up and install it. By the time that they get everything installed, then they find out it doesn't work. So it was just disastrous if you have a situation where you give out the equipment and 1/3 of the time, worse than Russian roulette odds, it was not working.
You needed to come up with a solution that replaced copper.
We had some users say that they can use Mocha. I think is that the word, right?
Yeah, it uses coaxial.
If you can do that, it's great. And it's really, really fast. But again, not everyone has that in place. So we really wanted a solution which is no matter where you are, I know that it works 100% of the time.
After you talked about this, I was a little not hesitant. It was just I've used Ubiquity gear before. I've used TP-Link gear before, And a lot of times it's felt very Soho, SMB-ish, and they felt cheap. So I went out and bought the same stuff that you used and set it up and had an amazing experience. So tell us about your experience using the Ubiquity Nano Stations as the replacement for the wire part.
The Nano Stations, I've been using older models. I've used older models several years before, and I always knew that they were very reliable. I knew that you could get very, very solid 150 megabit per second. But now they came out with a new product that supports QAM 256, and you can push up to I've pushed over 500 megabit per second using an 80 megahertz channel. And so my experience with it was that whenever we deployed it, we just forgot about it because we didn't get complaints after that. You put it in, we put something in 3 years ago and we've never heard back from the customer again. This is an outside customer.
I just have one question. I mean, I had a whole bunch, but just one. Is this thing mounts? It's made to be pole mounted. It has a little zip tie. How do you get these to aim them very well?
That is one of the more challenging aspects of this. I've actually shown a picture where I took one of these salad bottles and I actually mounted on a salad bottle just to show that you can mount it anywhere. Another instance, I mounted on light poles. So, sorry, not a light pole, a lamp post. So anything with a post, you can just zip mount it.
Is it very polarized if you change its reaction? I mean, it's got a 60-degree antenna, and I found if they match, I got better throughput. So
you do need to, if you're going to go vertical, they both need to be vertical. If you're going to go horizontal, they both have to be horizontal. You want them matching.
One really cool feature, well, I love seeing it. You can see the QAM. It's actually live QAM constellation diagram as you're running.
Right. You can see the QAM. It tells you what the data rate is. And it also the other feature is it's got a spectrum analyzer.
But I found that's only if you don't use DFS channels. If you use DFS channels, it's grayed out and it says you can't use it as long as you're on the DFS channel.
I think you can still do it on the client side. You can't use it on the AP side. But you can still fire up the DFS on the client side. So I would actually just get some of these just as a remote sensor, just for a spectrum analyzer.
And a pair of them was $150.
Right.
And Amazon got them to me in 2 days. So just if you want to play, here's a nice little thing to play with.
Our experience with this is that you can go through houses with this. They're really intended to go several miles with clear line of sight. But we're using it in a situation where we're not going through line of sight, but we're not going 5 miles either. So you lose a lot of distance, but so what if your distance goes from 5 miles to only 100 meters, right? 5 kilometers to 100 meters.
But that's a really big house, especially in Silicon Valley, if it's 100 meters.
That's crazy long distance.
I tried it in my house from upstairs, downstairs, and eventually, and I was getting 450 to 500 meg really consistently once I got them tuned in. Going from my house to my next door neighbor's house through 2 garages along the way, I was still keeping better than 200 meg throughput, and there was basically 2 houses in between of us. So impressed, worked well.
Yeah.
So how have your results been with the customers you put them in?
Like I said, they go up to 500 megabit per second, but generally I only keep them at 40 megahertz. So the typical speed is more like 250 because we don't need it. I try to keep the channels as narrow as possible for maximum reliability and to be a responsible neighbor and not waste spectrum where I don't have to. So anywhere, depending on the channel width, it's anywhere from 110 to 500 megabit, depending on the channel width.
That's good enough for doing Zoom calls.
Good enough for more than Zoom calls. I mean, it's not only is it getting you more stability, but it's also getting you more bandwidth. So instead of being stuck at 70, a lot of people are frustrated that they're paying for 300, but they're getting 70. And so we've been getting rave reviews because people are saying, hey, I've never seen, speedtest.net give me 300 megabits in my bedroom before, right? And now they're getting maximum speed
Why did you go with the TP links on as the endpoints? And also, I'll put two questions in here, and you can answer them both. And why two of them? There's a router that comes from whoever your ISP is that may or may not have wireless, and you opt to put in two home router / APs. Why two, and why did you pick TP link?
I like to kind of speed people on an access point as possible, even if they all have good perfect signal, because the more people you have contending for the shared medium, the worse the latency. And the latency is a bigger enemy than bandwidth in any real-time application. Most of the time, most people don't understand it, but Zoom generally only requires around 1 megabit in most use cases. The only time it goes up to 6 megabit is if you're doing high definition 1080p full screen conferencing. And most accounts don't even support that because generally you're limited to 720p. So that's 3 megabits. So it's not really a bandwidth issue that we're fighting with. What we're fighting for is airtime. And the way you can get more airtime is to put everyone on different APs and different channels.
Have you doubled this? Say that there was two spouses and they both needed to work from home as well as their children.
What we do is, if they have more people, we'll chain additional routers off of it. So we put everyone on their own AP in the absolute best case. Where so in terms of the most severe use cases, where they need absolute reliability, we will actually chain additional routers off of it and daisy chain additional routers off of it. So you're not really increasing the absolute throughput, but what you are increasing is the airtime potential for the amount of free airtime that you're giving people is much higher. So you're guaranteed very low latency.
In the picture, the one that's connected to the Comcast modem, that would be for children and family activities, and then work activities are on the second one on the other end of the bridge.
Depends on where they are. Sometimes we have people that work downstairs and their families upstairs. So we throw the spouse and the kids on the upstairs one, and then our worker is downstairs working downstairs, or it's reversed. So it depends on the situation. So we give them the option of they can figure out how they want to separate it themselves. We're just giving them extra capacity so that they have the ability to give out multiple access points. And we always name things differently so that the two reasons for that. One is I want them to be able to separate themselves, right? And two, I don't like it when they're named the same, because when you roam, you don't know for sure if you roamed over or not. Because a lot of clients, they like to hang on to the old access point, even if it's a very low signal. So yes, there are tools you can see which AP you're on if you have them, but for most people, it's easier if the SSIDs are different upstairs and downstairs.
Do you name them location or like work SSID, home SSID?
I just give them a generic name. You can name them and the users, they can rename it themselves if they like. So it doesn't really matter what the name is, so long as there's something different. What I tend to do is that I will put one of the 2.4 gigahertz radios as their old SSID for legacy support, because they might have a bunch of old devices that they don't want to reconfigure. So I tell them, look, for any serious work that you want to do on your phone and your laptop, only use the 5 gigahertz. The 2.4 is there just for all your legacy stuff. Just so we can keep all your streaming boxes off of your 5 gigahertz, that just makes it that much better, right? So essentially what we're giving them is 4 radios, and they can divvy up the capacity any way they want.
Do you offer any kind of parental controls for children getting different access or different throughput?
These devices, you can put things like time limits, right? So a lot of us that are parents know that you have kids that want to sneak some Wi-Fi time in at 2 a.m. in the morning. So you can put in, for example, time restriction. You can put domain restrictions if you want to block certain domains from access. They're not the best. These particular devices don't have the most granular level of control, but they have basic controls like total number of hours that they can use, and also what time they can use it, and certain domains that you might want to block.
Do you bundle this up with just the products and ship it to the home? Or do you send people on site to do the config?
No, we don't send people. Well, in the COVID era, you can't really send people on site. So even when we offer it, they don't want you showing up at their house. So what we do is we set everything up at the office, pre-configure everything, throw everything in the box. What we do is we don't package it back up in the box. We leave the cables connected. So a lot of the components, we just leave them connected because then it's less confusing. When you take it out of the box, the half of the devices are changing.
So the tail is connected to the router.
Right. So basically, the only thing that they have to plug in is the power and the cable modem. So once they plug that in, I tell them plug it in. The only ports that are available, plug it in, and then mount the thing any way you can on a light post, on a stupid salad dressing bar.
Do you help them to do there's a screen you can get to in the Ubiquity UI.
I tell them don't even worry about it. I say as long as you are in the general direction, if you just say, okay, well, it's somewhere that way, a little bit up, a little bit to the left, a little bit to the right. I do give them access to the admin credentials so that they can go into the web interface, or they can even install the app on their phone and look at the signal level. But in my experience for the home, it's so forgiving that because we're not trying to go 40 miles, right? So you don't really need that level of precision. I mean, if you were using the larger dishes or the 60 gigahertz products, those you have to be really, really dialed in to make them work. But these, you could be off by 30 degrees. We had one person that was off by 90 degrees, like literally the worst case, and it would still work because the distances were just not that long.
When you're setting these up, do you set up the SSIDs? Like there's a SSID for the bridge link, and do you lock that one down so they can't change it into client mode?
No, we don't. Well, we give them the password for it, so they can change it. But generally, most people they know better than to screw with it. We set everything up based on a script. I mean, I put up some training materials and give our desktop support the configuration, and then they go through the script and they just set everything up like a cookie cutter template. Because we're not trying to make it too complicated here. We've had users add daisy chain additional routers off of it that has additional child controls. So they have the option of expanding it. What this really does is it puts down the critical infrastructure, because that Ubiquity link is so critical because it allows you to reach other parts of the house that you could not reliably reach before.
And inexpensively and very simply. Especially, I mean, I did factory defaults on mine just so I could go through the experience. And it did take a while to figure out which end them on. And they come up with a management SSID for a while, and then you wire them up, and they need PoE. So, but if you give them to them already pre-configured, that's a really fast solution.
I was asked to just put out the documentation and let the users do it themselves. And I told them, look, you're going to spend more time on the phone support trying to help the users figure this out themselves than if you simply pre-configure it for them and just gave it to them. Because it's not easy. I mean, for us, it's easy. For someone like you, for someone like me, we can figure this stuff out. But I don't think it's something that you can give to the general user population and tell them to set it up from scratch.
On the Ubiquity side, are you using AirMax or the Wi-Fi? It'll do either.
Using the AirMax mode. I'm doing their proprietary mode. It doesn't even support Wi-Fi. You cannot, for example, you cannot turn this into a long distance access point.
But you can turn off AirMax and have it just be 802.11. And then it gets restricted to 20 and 40 megahertz channels.
They're using their proprietary stuff to make the latency lower. So I use whatever proprietary configuration that they have.
And for Wi-Fi guys, you need your little channel chart because it doesn't use channel 36. It uses the numbers. And another thing you could do, because it's Ubiquity, is I could set it down to a 5 megahertz wide channel or a 10. If it was a really congested area, I could use a pair of these, and with only 10 megahertz wide channel, I can punch through a lot of noise.
Yeah, they offer the 5 megahertz mode for ISPs. So, for example, it gives you, the narrower the channel, the longer the distance that you can go. So it's mainly for a rooftop deployment where it's a particular ISP just wants to sell a reliable 20 megabit to someone. And so that 5 megahertz and 10 megahertz mode is really, really useful.
It's just a little different for Wi-Fi people to see what, 5 megahertz? Where did that come from?
I wish Wi-Fi supported 5 megahertz.
I do too, but that's not in the cards right now.
I'd like to thank George O for his kind of unique solution to a problem that a lot of us have had. A lot of our customers have a difficult time either with mesh or finding a way to have a cable-free connection inside of a house to give the workers who are working from home the fastest low latency connections they have. So, very inexpensive, $150 solution. Use some Ubiquity nano stations connected up to access points will allow you to give low latency, fast connections to users throughout their home.